Alright, ladies and gentlemen, so we have been working very hard on the prior sections. Now let's go to section 4.8. Okay, so section 4.8 in this next video basically involves solving equations by using the zero product rule. Sounds complicated? You already know it. That's how funny this is to you. So for example, if you have, this is example 1, if you have been given an equation that says 2x squared minus 5x is equal to 12, as one example, you are in essence going to simply subtract the 12 and bring it to this side of the equation, canceling it on this side and leaving you 2x squared minus 5x minus 12 is equal to 0. Now you notice I cannot add these two because they're not like terms, okay? Now, I cannot simplify by dividing by 2 even though the leading coefficient is 2, because that's a prime number and it's a 5, it's an odd number. So what I'm going to do is I'm going to use the AC method, or we can also use guess and check since I haven't really gone over that much. Let's do guess and check. So in guess and check, you're going to start with the front coefficient or the front term, which is 2x and x. And now you got to figure out a way to get a 12 going on by using these two values. But the end result in the center, which is a sum, that has to be negative 5. So I'm thinking that 3 and 4 would work because I know that if I use the 4 outside, that'll give me 8. And if I use the 3 on the inside, 3 times 1, remember these are, that would give me a 3, and 8 minus 3 would give me the 5, so that would work. But now the signs, obviously this has to be the plus, and this has to be the negative. Because see, the outer term is going to give me negative 8x, the inner term is going to give me positive 3x. So negative 8x plus 3x, well that's going to give me the negative 5x I'm looking for right here. The negative 12 I obtained from positive 3 times negative 4, so that checks out. And obviously 2x times positive x is also checking out, so we're good. So we have these two factors right now, and now that we just need to set them to 0. That's all this means. It's everything you've already done. So if I set that to 0, all I have to do next is solve. So if I have 2x plus 3 equal to 0, I'm going to subtract the 3 on both sides. That gives me 2x equals negative 3. And now I'm going to divide by 2 on both sides. That leaves me x is equal to negative 3 over 2, so that works. The x minus 4, I'm going to set that to 0. That's one step. So I'm going to add that 4, right? Always do the opposite. So I end up with x is equal to positive 4. And now we check. We check to make sure that this works and it is part of the solution. So I'll start with the 4. 2 times 4 squared minus 5 times 4, is that equal to 12, yes or no? So this gives me 32, because remember this is 16, 4 times 4 is 16, so 2 times 16, 32, minus 20, is that equal to 12? And we can see, yes it does. We do the same thing with that negative 3 over 2, so 2 times negative 3 over 2 squared minus 5 times negative 3 over 2, is that equal to 12? Well, let's see. This is going to give us, technically this will become 2 times 9 over 4 initially, right? Minus, the minus 5 times is actually plus, so negative times negative, so 15 over 2, and is that equal to 12? Remember the 2 is going to cancel with the 4, leaving you 9 over 2. Is 9 over 2 plus 15 over 2, is that equal to 12? Yes, it is, because that's going to give you 24 over 2, which is 12. So they both check out, they're both a solution. We always check. So your solution set for this will be negative 3 over 2, comma, 4. Alright? Let's do example 2. More of the same. Example 2. When you look at example 2, remember you can always rewind this, by the way. In example 2, you have solve, and then they give you 6x squared plus 8x is equal to 0, excuse me, is equal to 0. So in this example, we actually want to factor out something that's common between these two, and I'm thinking 2 and an x. So I need a 3x and I need a 4. Set that to 0. So whenever you see this, see how this is hanging out in front of the parentheses? That is a repeating 0. So that means that we're going to say then 2x equal to 0, divide by 2, so therefore x is equal to 0. You don't need to do all that, but that's how it works. Here's 3x plus 4, we set that to 0. Subtract 4 on both sides, so you get 3x is equal to negative 4. Remember this cancels, plus minus of each other, leaving you x is equal to negative 4 over 3. And again, you always want to check and make sure that this is true. Obviously, if I plug in 0, they both become 0, so this is true, this works. And if I plug in negative 4/3, this also will work. Okay? Just to prove it, 6 times 0 squared plus 8 times 0 is 0, right? That checks out. 6 times negative 4 over 3 squared plus 8 times negative 4 over 3, is that equal to 0? Is the question. So this becomes 6 times 16 over 9 plus negative 32 over 3. Alright, and just to prove the math, we could either reduce at this moment. If you reduce, that would make life a little easier, but if we just multiply across, we could see the math behind it. So just multiply here. So 6 times 16, you have 96 divided by 9, plus, well, first of all, let's find out 96 divided by 9, what does that give you? It gives me 10 2/3. Okay, and then from that we're going to take the 32 and we're going to divide that by 3. And that gives us 10 2/3. Positive of the same, minus of the same equals 0, checks out. Alright. Let's look at example 3. In example 3, you have 9x, parentheses 4x plus 2, minus 10x, and we're going to set that equal to 8x plus 25. And so at this stage, we would simply distribute. When we distribute, we get 36x squared plus 18x minus 10x is equal to 8x plus 25. If I collect the like terms, notice this is a plus, this is a negative, so I end up with 36x squared plus 8x is equal to 8x plus 25. Okay, obviously these guys cancel, right? Because I'm going to subtract an 8x one way or another, and they're both going to cancel. And so leaving me 36, and then if I subtract that 25 and bring it over here, I'm left with 36x squared minus 25 is equal to 0. And now I can actually use, in this case, the product of sum and difference, right? We learned that in the prior section. Difference of squares. And so if I take the square root of this side and this side, I end up with 6x minus 5 and 6x plus 5. And both of those are equal to 0. So I have two solution sets here, or two solutions in the set. I have positive 5 over 6 and I have negative 5 over 6. We can always check them by plugging them in, and I'm gonna give you a heads up, they both work. Alright. Example 4. In example 4, we're doing more of the same. We're going to solve. And so I have 2x times x plus 5 plus 3 equal to 2x squared minus 5x plus 1. And so the first thing I would do is I would distribute again. This will give me 2x squared plus 10x plus 3, and that's equal to 2x squared minus 5x plus 1. What you'd want to do is collect all like terms, so I'm going to subtract the 2x squared and bring it over here to this 2x squared, and guess what? They're going to cancel because they're both alike. I'm going to add the 5x and bring it to this side, and I'm going to subtract that 1 and bring it to this side. So if you notice, everything on this side goes away. It's 0. That's 0. This gives me 15x plus 2 is equal to 0. And now I can actually solve. If I subtract the 2 and bring it back over here, this gives me 15x is equal to negative 2. Notice that went away. And then I'm left with x equals negative 2 over 5, and 15, and that is my solution set. Okay. Now, the easiest question of all, which at first looks ridiculously ominous, example 5. In example 5, this is solving a higher degree polynomial equation. So here we are. In this equation, what we're going to do is we're going to solve. We have negative 2 parentheses y plus 7. We have y minus 1. We have 10y plus 3. And all of this is equal to 0. So it's already factored for you. This is why it looks ridiculously difficult, but it's actually very easy. Because I know that when I look at this, I'm going to actually look at it in parts. In negative 2, for example, there is no solution. When I look at this one, the solution, if I do y plus 7 and I set it equal to 0, I get y is equal to negative 7. That's a solution. The keywords here are or. So or, this is an or. If I have, in this case, y minus 1 equal to 0, then y is equal to positive 1. Again, or. And then lastly, if I have 10y plus 3, and I set that to 0, then I'm going to end up with negative 3 over 10 as a solution. Because you're going to subtract the 3 first, then you're going to divide by 10. So when we talk about these solutions, we can always check them and plug them in. And we end up with -7, +1, -3/10, and these three are our solution set. So it's not that bad. If we look at example 6, more of the same. We have solving a higher degree polynomial equation, and it says basically solve. And so we have z to the third plus 3z to the second minus 4z, and minus 12 is equal to 0. And so what we were going to do here is we literally are going to use factor by grouping, so nothing changes. We're going to split this as such, and we're going to take out the z squared from this side because that's our highest or lowest potential variable. There are no coefficients that actually match. This leaves a z plus 3 on the inside here, correct? Looking on the opposite side, if I take out a -4, I could use again that z plus 3. And remember, this is equal to 0. So this actually gives you z plus 3, and this becomes z squared minus 4, and all of that equal to 0. Keep in mind this can still be factored further because it is a perfect squares and a negative, so we can use the a minus ba plus b. So in this case, z minus 2, z plus 2 equals to 0. Now if we test it, plug them in, you see that we have 3 solutions. So in this case, the solutions are -3, +2, -2. Okay? And that is your solution set. Alright, very good. Example 7. So in example 7, we have a word problem, and it says the product of 2 consecutive odd integers is 35. Find the integers. Now, in all honesty, can we agree that the numbers should be 7 and 5? They are 2 consecutive odd integers. And if I multiply 7 times 5 or 5 times 7, I get 35. So the idea is going back to looking at the equation as x times x plus 2, if you recall, and this is equal to 35. And if I use this, I end up with x squared plus 2x minus 35 is equal to 0. And so my factors have to be, in this case, x plus 7 and x minus 5 equal to 0. And therefore I have x is equal to -7 or +5. Okay, and I believe that that would solve our question. +2x. According to the textbook, another possible set of the are -7, -5, 5 and 7 as possible combinations. If you're factoring this is your answer, period. Okay, just keep that in mind, in the back of your mind, just in case. Example 8. In example 8, you have a basketball court, obviously a rectangle, right? If you have a rectangle, and it says the length of the basketball court is 6 less than twice the width. That's what that looks like. The total area of the basketball court is 4,700 square feet. Okay, and then it wants you to find the dimensions of the court. So just remember that area is equal to length times width. In our case, our length is equal to twice the width minus 6. So if we multiply this out, so we multiply this out by filling this in with what's given. We have 4,700 is equal to that length, which is twice the width minus 6 times W. Alright, so if I multiply this, I get 4,700 is equal to twice the width squared minus 6W, because all I've done basically is distribute backwards, right? If I subtract the 4,700, or, which I would do, I'd just subtract the 4,700 and bring it to this side of the equation, because you always want the leading term to be positive in these cases. So now we have 0 is equal to 2W squared minus 6W minus 4,700. Okay, so at this point we need to think critically. First of all, I'm looking at these numbers and I can see they're all divisible by 2, so I could do that first. If I do that, I have 2 times W squared minus 3W minus 2350, which is the equivalent. And of course, remember that's equal to 0. Okay, and now I can factor this. Now I'm thinking it ends in 50. Let's use 50 as a factor. That's a hint. So 2 times W minus 50. If I divide that by 50, then this should be a W plus 47, because they have to be 3 units apart, so that would make sense. And again, that's equal to 0. 2 is not potentially a solution. This could be a solution where W is equal to 50. This, although W will equal negative 47, there's no such thing as negative 47 as a solution. So in this case, the width has to be 50. If that's the case, then our length, which is equal to twice the width minus 6. So 100 minus 6, 94 feet. Once you substitute that in there, because you get 100 minus 6 is 94. This is just one of the several application questions. There is only one other topic I want to cover with you real quick, which I think is very important. That's Pythagorean theorem. And they do have a question on that, which I can discuss with you. Let me see what else we have. Let me talk to you about Pythagorean theorem real quick. And so in this example, you have a word problem that basically says a region of a coastline off Biscayne Bay is approximately the shape of a right angle. So it kind of looks like this in the drawing. And they put a bunch of green stuff over here. Alright, it says in this case, this value here is x, and this size here is x minus 0.5 in the question. They also tell you the hypotenuse is 2.5 miles. Okay, so if we plug this in, we have a squared plus b squared equals c squared. Okay, our C, this is C. Either one of these can be A or B, so let's call this A, let's call this B. So if I have x minus 0.5 squared plus x squared is equal to 2.5 squared, that's in essence the problem. Alright, so I end up with, after using FOIL on this, because remember that's x minus 0.5 times itself, this will give me, in essence, one second here. Okay, so we have, in this case, x squared minus 2 times x times 0.5 plus the 0.5 squared, and all of this plus this x squared is equal to 6.25. And so now we just wrote like terms. So we should have 2x squared minus x minus 6 after I subtract that and bring it over. This is all equal to 0. And now using trial and error, I guess, I could use 2x and x. And I'm going to need a plus 3 and I'm going to need a minus 2 here. Because the outer term is going to give me a negative 4 and the inner term is going to give me a positive 3x, so therefore that value. So notice that this is automatically going to give us a negative number, so this is not potentially a solution, whereas this one is going to give us x is equal to 2, and that is potentially a solution. Alright, so therefore one leg of the triangle has at least the 2 miles. Alright, so I hope this has been helpful to you. This video is, again, an abbreviated version of what we cover in class. So it's designed to help you, but it is not all of the lessons. So if you have questions, let me know.